Okay, ladies and gentlemen, the next set of problems have to deal with functions that have radicals, and I really need to do a little bit of groundwork there before you're really going to understand how to do those problems. So let me just do a little bit of reviewing here, okay, when it comes to the concept of radicals. If I write something like the square root of 25, you know that that's an implied, the index here, which is the number in the pocket, if it's not there, it's an implied 2. And what you're asking yourself is, what times what gives you 25? And of course, whenever the index is an even number, the answer has to be positive. So the answer, of course, would be positive 5. Now, the important thing to keep in mind here is the number underneath is very important. When you're trying to find the square root of a number and you want the answer to be a real number, we have some restrictions on what you can put under the radical. For example, if I tried to take the square root of negative 36, I would end up with an answer, but the answer would not be a real number. If you recall, the square root of negative 36 is 6i, but that is not real. Now, in our discussion of functions, we're trying to get answers that are real. So for that reason, here's something you need to know. Anytime I'm taking the nth root of a number, okay, n is the index. When n is an even number, all right, when n is even, like a 2, a 4, a 6, an 8, and so on. Anytime I have an even index, the quantity underneath here has to be greater than or equal to 0 to get an answer out that's a real answer. So whenever you're dealing with radical functions, the first thing you need to do is to pay attention to the index. If the index is even, we have something that we have to adhere to. Whatever is under the radical, the quantity under the radical, has always got to remain greater than or equal to 0. We can take, for example, the square root of 0, we can take the square root of a positive number and get a real answer. But if I try to take the square root of a negative number, like I did up here, it's not real. Now, let's think about odd roots, okay? If I ask you to find the cube root of 8, what times what times what gives you 8? Hopefully you would get a 2. What if I said find the cube root of 0? What times what gives you 0? That would be 0. What if I said find the cube root of negative 27? In other words, a negative number under a cube root. What times what gives you negative 27? Well, the answer would be negative 3. So notice the huge difference here. When the index is odd, we are okay. There's no problem. You with me? The only time you ever have to worry is when the index is even. For example, a square root, a fourth root, a sixth root, an eighth root. Those are the times that you have to be careful what goes under the radical. When the index is odd, okay, when I'm taking the nth root of a number and n is odd, no problem. I'm going to get an answer that's a real number automatically. But that is not true if the index is even. So, keep this in mind for our next discussion. Whenever you're trying to find the domain of a radical function, a function involving a radical, the first thing you have to do is pay attention to the index. If the index is even, we have some concerns. If the index is odd, like a cube root, a fifth root, a seventh root, we have no problem and the domain will be all real numbers. Okay, so this is just a little precursor for what's coming.